Welcome to the video on function inequalities. First, we'll talk about solving inequalities. So if you have some function g of x is greater than or equal to another function f of x, you'll solve it just like you solve a normal equation, except if you divide or multiply by a negative, the less than or greater than sign will switch directions. So here we have two quick examples. So it says negative 2x plus 5 is less than or equal to 11. So we want to solve for x. So we're going to subtract 5 from both sides. So we get negative 2x is less than or equal to 6. And then we're going to divide by negative 2. So when we divide by a negative, we're going to flip our sign. So we get x is greater than or equal to. And then 6 divided by negative 2 gives us negative 3. So there's our solution to the first one. For the second one, we're going to shift everything to one side and set it equal to 0. So we'll subtract x squared, subtract 5x, and subtract 4. X squared minus 5x and minus 4. So this will give us that x squared minus 2x minus 8 is greater than 0. So we need to find what multiplies to 8 and adds to negative 2. So that's going to be negative 4 times positive 2, and negative 4 plus positive 2. So that's going to be greater than 0. So this function will be equal to 0 if x equals 4, because this would be 0, or if x equals negative 2. So we're going to draw a quick number line to help us know which sections where our original function on the left would actually be greater than our function on the right. So we'll draw our negative 2 and our positive 4. If we plug in a number smaller than negative 2, negative 3 for example, we'd have negative 3 minus 4, which will give us a negative number, times negative 3 plus 2, which will give us another negative number. A negative times a negative is a positive, so this section is going to be greater than 0. Now we can try something in the middle. We'll plug in 0. If we plug in 0, we'll get a negative times a positive, which is going to be a negative. So our middle section is not greater than 0. And then finally, if it's greater than 4, so 5 for example, we'd have a positive number and a positive number, and a positive times a positive is a positive. So our function will be greater than 0 here and here. So if x is less than negative 2, or if x is greater than 4. So that would be your solution to this equation. Next, we'll learn about graphing inequalities. So if you have one variable, then you'll just graph it on a number line, as shown down here at the bottom. So if x is greater than or less than, you'll put an empty circle on the solution. So it'll be a circle like this because the value itself is not included. If it's greater than or equal to, or less than or equal to, you'll put a filled in circle. So it would look like this. You would fill it in because it's also equal to. So the difference is having the equal to sign on the bottom. For x is greater than or equal to the number, you'll draw an arrow to the right. So your arrow will go this way because it's going to be greater than. It'll go towards the bigger numbers. And then for x is less than or equal to the number, you'll draw the arrow to the left because we'll have the numbers that are less than that. So this one here is x is less than negative 2. Since negative 2 is not included, there's no equal sign. It'll be the open circle like it shows here. And then it's going to the left because x is less than that. For two variables, you'll graph it on an xy plane. So you'll graph the equation like normal, but if y is just greater than or less than, you'll use a dashed line. So it would be something like this to show that it's not actually equal to the values on that line. If it is greater than or equal to or less than or equal to, you'll use a solid line like this, showing that it's also going to be equal to those values. For our greater than or equal to, we'll shade above the line. So here we'd shade above and above and above. For less than or equal to, we'll shade below the line. So it would be like this, around it. So I always like to think if a person was standing on the line, that's our greater than. So if you had a function like this, and a person was standing on the line, that's where the greater 2 area is going to be. So you would shade up here. And sometimes it gets confusing with functions like this, but you can always think if someone was standing on here, that's where the greater than is. A helpful tip is if you still aren't sure where to shade, you can try plugging in a point and seeing if it's a solution. So if you had a graph like your squared function, and you're not sure if you're supposed to shade out here or in here, you can plug in this point, whatever number it would be, into your equation. And if the equation is true for that point, then you would be shading the outside area. But if it's not true, then you would shade the inside area. So here we have a graph of y is less than x squared plus 3. So you have your line for x squared plus 3, and it's dashed because it's not equal to, and then it's less than, so they shade the area outside of the graph, or below the function. So here we have our first IB practice question, which is no calculator. It says solve and graph the inequality x squared is greater than or equal to negative x plus 12. So we want to make one of the sides 0, so we'll make this side 0 by adding x and subtracting 12. So we have x squared plus x minus 12 is greater than or equal to 0. To factor it, we can see what multiplies to negative 12 and adds to 1. So it's going to be 4 and 3, and our 4 is positive. X plus 4, x minus 3 is greater than or equal to 0. So we'll find our zeros. So this would be 0 if x equals negative 4, and this would be 0 if x equals 3. So we'll graph our negative 4 and 3. If x is negative 5, we'd have negative 5 plus 4 times negative 5 minus 3 is greater than 0, or equal to 0. Negative 5 plus 4 is negative 1. Negative 5 minus 3 is negative 8. A negative times a negative is positive, so it will be greater than or equal to 0. So our area over here to the left is going to be solutions. Now we'll try our middle section. So we'll plug in 0. If we plug in 0, we have 4 times negative 3 is greater than or equal to 0, which is not true. So the middle section will not be shaded. So we can look back at our negative 4. Since our function is greater than or equal to, our negative 4 is included. So we'll put a dot there. So now we'll look at the things to the right of 3. So we'll plug in a 4. So 4 plus 4 times 4 minus 3 is greater than or equal to 0. So that's 8 times 1 is greater than or equal to 0, which is true. So 3 will be included because we have an equal sign, and then everything to the right. So this is how you would graph the function. It's important, in order to get full marks, that you do your filled in circle and that you show which way the arrows are going. And you also need to write your solution out as x is less than or equal to negative 4, or x is greater than or equal to 3. So this one is an or because they're going two separate directions. You can't be less than this and greater than. Your solutions are going to be the values below or the values above. You would use and if your answer was that x was between negative 4 and 3. So x would be greater than negative 4 and less than 3 because it would have to meet both qualifications for the solution to be correct. Here's our second IB practice question, which is also no calculator. It says solve and graph the inequality y is less than x squared minus 5x plus 6. So we want to start by graphing our y equals x squared minus 5x plus 6. So to do this, we can start by finding our line of symmetry, which will be x equals negative b over 2a. So that would be negative 5 over 2 times 1. So that turns into 5 halves. So on our graph, we'll have 1, 2, 3, 4, 5. So 5 halves is our line of symmetry, so that's 2.5. So here we have our line of symmetry. We can plug in 5 halves to figure out where the vertex is. So y equals 5 halves squared minus 5 times 5 halves plus 6. 5 halves squared is 25 over 4 minus 25 over 2 plus 6. This would be 50 over 4, and this would be 24 over 4. So 25 plus 24 is 49, minus 50 is a negative 1/4. So on our line of symmetry, we'll have our vertex at y equals negative 1/4. So we'll draw some negative numbers. So here is where our vertex will be. So that's 5 halves negative 1/4. When x is 0, y will be 6. So we'll have 1, 2, 3, 4, 5, 6, a point here. And then that can also be reflected to the other side. So it'll be at 5, 6. It says y is less than that. So since it's not equal to, we're going to use a dashed line. So our line will look something like this. And then y is less than. So since it's less than, we're going to shade underneath the function. So all of these values where it's shaded are going to be solutions to our equation. So for example, if we plugged in 0, 0, then we would say y, which is 0, is less than x, 0, squared, minus 5 times 0 plus 6. This becomes 0, this becomes 0. 0 is less than 6. This is true, so we know 0, 0 is one of the solutions, so we did shade on the correct side. And our written out solution to this equation is just this right here. So this has already been solved. We just had to draw the graph because it was in a correct form to where it's solved for y. Finally, we have our third IB practice question, which is also a no calculator question. It says the function f is given by f of x equals 5 over 3 plus x for x is not equal to negative 3. Find when f of x is less than 4. So we want to find when f of x is less than 4. So our f of x is 5 over 3 plus x, and we want that to be less than 4. So we'll multiply both sides by 3 plus x. So we get 5 is less than 4 times 3 plus x. We can distribute the 4. So we get 5 is less than 12 plus 4x. Then we'll subtract 12. So negative 7 is less than 4x. Then we divide by 4. And we get that negative 7 over 4 is less than x. We can also write that with x first. That would be x is greater than negative 7 over 4 because we're swapping it to this side. And if you read it from this direction, x is actually greater than negative 7/4. So this would be our solution to this problem. X is greater than negative 7/4. In summary, solving inequalities is just like solving normal equations, except if you divide or multiply by a negative, the less than or greater than sign will switch directions. For graphing inequalities, if you have one variable, you'll graph it on a number line like this. If it's greater than or less than, you'll put an empty circle on the solution. If it's greater than and equal to or less than and equal to, you'll put a filled in circle on the solution. If it's greater than or equal to, then you'll draw the arrow to the right, and if it's less than or equal to, then you'll draw an arrow to the left. For two variables, you'll graph it on the xy plane, something like this. You'll graph the equation like normal. If it's greater than or less than, then you'll graph with a dashed line. If it's greater than or equal to, or greater than or less than, you'll graph with a solid line. If it's greater than or equal to, shade above the line, and if it's less than or equal to, you'll shade below the line. That's all for this video. Thank you for watching.